Okay, so the next lecture is another part of our project's lecture theme. If you remember, we did one last week on package management. Um, Today we're doing one on continuous integration. Continuous integration is a topic that is also new since I started teaching this course, which is how would you put it? It's a lecture that's motivated by the fact that when you work, like we've done this stuff with Git, where you learn how to use Git and you make merge requests and you do approvals and stuff like that. But to scale these multi-user software project environments, we need automated ways to integrate and test code. Basically, we need ways so that you can create these merge requests, merge them in, right, and help assist you in making sure that they didn't break everything. That the person who wrote the code didn't just destroy everything. So we're going to learn about continuous integration. We're going to learn about pipelines. We're going to learn about runners, all of these things. So continuous integration. Formally, we will define it, or it is defined, one or the other. It's the practice of automating the integration of code changes from multiple contributors into a single software project, which is a really fancy way, again, of saying that we make it easier to make sure that code changes come together and don't break anything when it comes from 5, 10, 15, 30 people. You look at companies like Canva or Atlassian, Canva's a good example, probably like 3,000, 4,000 engineers, I don't know, something like that. Kind of one code base that many of them work on, and you got code coming into the master branch every single day, right? How do they make sure it doesn't break everything all the time? How do we make sure that more frequent merges into master don't create instability? Fairly simple questions. And basically the way we get around this, and what continuous integration is that it is a process where we run a series of operations on any commit that's pushed to the repository to check if it works. So it's like an automated checker, and we tend to do it on a per commit basis. So each commit that happens, we go and figure it out that way. We go and actually do a few things, which includes building, testing, and some other stuff we're going to talk about in future lectures. Now, building is not something that comes up with JavaScript because we're rarely building things in JavaScript because it's an interpreted language. But what we do with JavaScript a lot is test, and we've seen that last week with Jest, haven't we? How you can actually test some things with Jest. Building in other contexts might more be like what you do with C, where you do GCC or DCC to actually compile it. Building can mean compiling as well, right? But in these cases, no, we'll just be looking at testing. There are other things we will do, right, with the continuous integration over the coming weeks. But to oversimplify it, all we're really looking for to solve here is that continuous integration allows us to automatically run NPM run test, or the Jest tests, on every commit. So you don't you're going to still do it locally, but we don't want you to kind of stress that if you did it wrong or you forgot to, that everything's going to break. And number two, we want to help give you a visual okay or not okay summary on GitLab so that you and your team can kind of really easily look at commits and be like, this commit is okay or not okay, And the way we're going to do that is we're actually going to add a really important file to your GitLab repository. So what I'm going to do, just to demonstrate this, is if I come to GitLab here, and I'm just going to make a new repo. You won't ever have to make a new repo, but I'll make one here. And that new repo, in this case, I'll call it CI test. Can be, it doesn't matter. I'll make it internal so you can all see it if you want to go look up this URL. I don't know if that means you can push to it. I don't think you can. But what I'm going to do now is I'm going to clone this. Have a look at this repository for a second. I'm going to open it up in a new tab again so we can look at it twice. We can come back to how it looked before. I'm going to clone it. Yeah, right. Here we go. Git clone, like that. Done. CI test. Cool. Now what I'm going to do is I'm going to follow the lecture slides, which is going to consist of adding this here, all this text, to a file called .gitlab-ci.yml. So .gitlab-ci, the dot makes it a hidden file on Linux. GitLab is obvious. CI stands for continuous integration. .yml is a .yaml file, so you can see all these pieces are kind of coming together a bit. And if I create that .gitlab-ci.yml and I paste that in, now what I'm going to do is I'm going to go and commit and push it. Right? Git commit adding GitLab-ci file. Push to master. Obviously in your project you wouldn't need to push and you couldn't push to master. This repo is using main, so master main, we talked about that back in week 1. Now watch what happens when I refresh the page. 2 really important things to pay attention to. The first one, a new file was added here because I made it, gitlab-ci.yml, right? It's got that stuff in it. Secondly, you'll notice that up here next to the commit, and have a look at the other tab for a second, right? Because I'll compare these 2 things side by side. Have a look at the difference here. Right, see how we've got this little like waiting sign here? Now what this is this is actually GitLab now kind of doing the checks on your code, or more specifically, what GitLab is doing in this case is it's running the automated checks based on the rules that are provided in this file. And we should break down these rules really quickly, and there's not a lot to them at this stage. They're all very straightforward. Right? So the first one is this image line. This one we'll come back to, but you kind of don't need to worry about it for now. These 2 lines, most of this you don't need to worry about for now. Maybe we will come back to a bit of it, but the main line to pay attention to is this line here, echo hello. And this is the actual kind of script or the shell that runs when the checks happen. So if I go back to my repo here and I click on the tick, because you can click on this, you'll see that it has a few things on this page. You'll see that it says it did a check called sanity. And if we look back at the code here, you can see that there's a check called sanity. Cool. And when I click on that, it's got a whole bunch of text here that I can mostly ignore, but you'll see there it actually ran that code right here. So that echo hello was run right there. Now the main point of this is not to kind of show you all these things and scare you. The main point of this is just to very quickly demonstrate to you, right? Very quickly demonstrate to you that we can write a little bit of code in here, like this, and it will run in here for us. So I could go and change that, right, on GitLab if I wanted to. I could say this echo another test, more exclamation marks. Then I could commit it. Then you'll see here that on GitLab, this is now a little waiting symbol again because we'll come back to what that is. It's doing its thing. It's doing its thing. It's checking. It's running that instruction, that automation that we've asked it to. And if I keep refreshing enough, it says tick, which means done. And if I come in here and I look in this again, you'll see that it doesn't say hello, it says another test. Okay, so what we've established now is that we have a method to actually write a little bit of command line stuff and have it run every time a commit's made. So that's really interesting. Let's move on and we'll come back to that, right? Because I've just talked about this with GitLab. And I've talked about this as well, right? These are just for the lecture slides so people can read it. we want to talk about how it actually works though first, before we get into how we can play around with it. And the way it works is that every time in GitLab a commit is pushed, all of the code, if there is a .gitlab-ci file in that repository, what GitLab does is it takes all of the code in that commit and it gives it to another computer. Like imagine a laptop sitting out in, an office down the street. It gives it all to that computer, and that computer runs all of the instructions for it. Like it goes and runs that echo hello, or that what's the other thing, like that echo, and what did I say, another test something. It just goes and does that for us. So that's a really important distinction, because how it actually works here is that if you have a repository, your group's repository, and then your friends in another group have another repository, both of you are all working on each other's on your own computers, right? So like group one has, there's a few people in that group, everyone's working on their own computer. They're all pushing, they're pushing up to Git and syncing with Git. And then another group over here is working on their computers and pushing and syncing up to Git. But every time each of those groups pushes, each repository, whether it's your group or another group, packages up that code on the commit and sends it to a computer that we call a runner, we call it a runner in this course, which is essentially a computer that's job it is to run code for us. That's it. It just runs code. So a runner is just another name for a computer whose sole job it is to run pipelines. We'll talk about pipelines in a sec. But it's just executing instructions. For commercial websites like GitHub and Bitbucket, typically what they actually do is they have runners built in. So like, if you go to like Bitbucket has like these computers like packaged into their service that they use, and typically they give you a little bit of it for free. Yeah, so basically, the way a company like Atlassian's Bitbucket, the way a company like Atlassian has their tool Bitbucket work, is that they will, if you create a Git repo on their service, you could do this yourself, unrelated to 1531. You will be given 50 minutes of a computer's time a month to run instructions, and after that, they'll start charging you, or it simply stops working. That's kind of the case. GitLab, GitHub, what do they call GitHub's ones? Actions pricing. I can't remember what it's called. Free GitHub has 2,000 minutes a month of this stuff, I believe. A lot more. 50 is plenty for a normal person, but 2,000 is quite. What is it? How much is that a day? So 2,000 divided by 30. Right? 60 an hour a day. That's a lot. That's pretty extensive, right? Great. Cool. So lots of cool stuff. For something like GitLab, though, the thing we use for the course, what actually happens with GitLab is that because it's an open source platform, we actually provide a runner. So the runner's actually sitting in CSE, the building. So if you have ever like gone into the computer science building, the actual computer that's running all of your like, or will soon run all of your GitLab, little ticks and things, is all actually just, sitting there running all the time. It's a dedicated computer that CSE manages. Bron says, so is this just a feature we're getting through UNSW for free? Yeah, kinda. Like, in theory, your 1531 projects could use thousands of hours in theory of like the runner's time because the school's providing it. And in reality, you'd probably have to pay for that or provide your own computer. Like a lot of bigger organizations won't use like GitHub or Bitbucket's like computers to do the running. They'll actually like have their own and ask Bitbucket or GitHub to actually like use another computer instead, which obviously is going to be fine because it's, it just works. When I say ask, I don't mean you have to call someone up and ask. There's just settings that you can change. But yeah, so GitLab, the runners aren't built in. We've set up a runner for you. It's managed by CSE. Pretty straightforward. I had something I want. Oh yeah, pipeline. I was like, I have something I want to tell you. So the term pipeline has been thrown around a bit. So I just want to get the language really, really right for you, which is that the way I'd say it is that you have a GitLab repository. It has a .gitlab.ci YAML file in it. When that YAML file is present, every commit you make, GitLab notices that file. It packages up the code. It gives the code to a runner, and that runner runs a pipeline. A pipeline is the set of instructions defined in this file. So you could kind of describe this file as a pipeline instruction. We call it a pipeline because a pipeline is made up of a series of jobs. And you can kind of see that sometimes here when you actually see that there's, if I go to like your own, my GitLab repo here, you could do this for your own. There's actually a section called pipelines where it shows you all of the pipelines that have run. And remember, pipelines are typically generally related to commits. So I kind of did 2 commits with this gitlab-ci file. And therefore you can see that I've got 2 pipelines. But pipelines are made up of more smaller jobs. And those jobs are the actual kind of executed code. So if I go to jobs here, you can see that there's been 2 jobs that have been run. Right? Which makes sense because the pipelines had 1 job. So I can actually click on, say, the first pipeline we ever ran 8 minutes ago, and you'll see there's 1 job in there, which was the, the print thing here. So pipelines, series of jobs. A pipeline runs when you commit code. those series of jobs run. Let's dig a little bit deeper now together, which is configuring it. So now let's actually get ourselves set up with NPM. So this is another good chance to revise things very slightly and say, well, let's actually go and quickly put some code here inside the CI test folder. You know, let's go and steal some stuff. What's some testing we have from the last lecture? We got an export. Yeah, let's try this one. So let's take our I'll copy our lectures env1 source 2.3 jest lib.js, right? I'll copy that here. I'm also going to copy our .lib.test.js here. And I'm also going to create an empty package.json, which again, you'll never have to do, but I'm going to make one here. Now, let me open this up in the text editor so you can actually kind of see the structure a bit. I'm just kind of, you know, getting together a few little things. Again, you never have to make this package.json because we kind of make it for you all the time. But what you'll notice is that I have to actually import Jest because I'm using the Jest library. So like I did last time, I will npm install savedeb Jest, which will install the library into the package.json. Because without it, if I tried to put this up on GitLab, GitLab would try and run the code, right? And it would basically just not work. Because it's like, I don't know where the library is, just like we talked about last time. So now that that's been installed, and just a quick recap, now that that's installed, I have a node modules folder, right? Which you can see here, node modules. I've also updated, you know, my package.json to have that dev dependency. I'm going to go and commit all these files. I'm going to do something. Oop. Notice this. Notice I've got this node modules folder here. I don't want to commit that, so I'm going to go make myself a .gitignore file. Node modules, like this. Now it's been ignored. I'm just going to go and add everything, which I shouldn't normally do, but I'm going to do in this case. I'm going to call it adding Jest testing files. I'm going to push it up to GitLab. This didn't work because I modified the file on GitLab, right? Do you remember that? So the commit history, this is back to our very first lecture in the course. The commit history here is different because I updated this on GitLab, whereas if I look at my local commit history, I've only got adding gitlab-ci file here. So there was a commit made on GitLab and a commit made on my local. You've probably seen this before if you've done parts of iteration 0. How do I solve this? I git pull, which does the merge commit. This is all back to the very first lecture. I exit this. Now I can push. By now I'm hoping you would have seen a lot of this. And if we go back to GitLab, you'll see now that nothing's changed in terms of the pipeline, but my files are there. So in theory, what I should be able to run locally now is npm run test, right? Oh, sorry, npm run test. But what it says here is it says no test specified. That's because the test script here is designed to do that. But what I actually wanted to do is I actually wanted to run Jest on 2.3 lib.test.js. So npm run will run a script. That script in this case runs that Jest command. It says so there. And it should work unless I've copied the code wrong. Okay, it says it's failed because I'm missing a file. By the way, me and some tutors were talking about this, but one of the things you should do, seriously, if you ever want to work on your own stuff like this, like what I'm doing in the lecture, you should not do what I've just done and create a new repo. It's not a smart idea because there's a lot of like fiddling that we have to do to get some of your things working. So what I would generally recommend is that you go to a lab that's at a similar point in the course, you clone that and you remove the files. Because for instance, there's this really random annoying file that you need to make things work called .babelrc. And if you don't have that file, nothing seems to work. There's some long complicated stories about JavaScript here, but you see this should work now. No, I got other problems. Oh, that looks like a big problem. Oh, I have to, yeah, see, there you go. What do you notice about the labs? If you've looked in all your labs, you'll see in the package.json, we not only include Jest, but we actually include this other library here. You know, see, the thing about JavaScript is that, you know, it's a really young language, which the problem, I talk about this a bunch, but it's just like, because it's so young, people are improving it at an enormous rate. It's an insane time in computing for JavaScript. Things are just moving all the time, and it's incredible what the tech is doing. But because of that, there's a lot of patches on patches, which means that to give you some of this more modern stuff that we work with in the course, I didn't install it. I just added it to package.json. I shouldn't have done that. I should have just run in. I'll show you what I should have done. I shouldn't have just added it here. I should have gone here and I should have gone npm install, you know, that library. Like that. And I should have made it a dev dependency with the -- save dev thing. I forgot that. And now it's going to get put in a different spot inside of package.json. Right? Let me close that and reopen it. Oh, no, it figured it out. I wonder how it knows that. That's so interesting. Now when I run it, it will work, I'm sure. Yep, worked. Ooh, scary. So, that's cool now. So what we want to do with the pipeline is, rather than us have to run npm run test every time we make a code change, I'm going to go and update the gitlab-ci file to simply run, instead of this echo text, I'm going to say npm run test. So remember, the gitlab-ci file is just an instruction of what code to run that you would already run on the terminal. It's nothing fancy, you know. It's just literally what you would run on the terminal, but put it in this file so GitLab and the runner will run it for you. So now when I go and, you know, git status, and I go and I got to git add these files. I'm just being lazy because it's 7:30 and I don't want to go through like 2 minutes of correct git practices every single time. Right, push that up to GitLab. Now what you'll see, if I click on the pipeline here, right, is that there's one job still, and when I click on that job, it's still running. You can see there's a few different states for the pipeline. The first one you saw with the pause symbol, that's called waiting. What that's actually doing is that it is waiting for the runner to be free. Because the runner, just like most things in the world, can't just do everything at once. You can only do so much at once. So that's it saying I'm waiting until the runner's ready for me. And then the blue moon thing is when it's running. That's it saying the runner is running me. And then at the end of that, it either ticks or it crosses if it succeeded or failed. So in this case, you can see it actually ran that command there which succeeded. And that's really cool, because now in my little repo here, because of that file, I get this little tick which is saying, you know what? Your Jest tests are passing. Good job. And the reason that's exciting is because let's say you go and accidentally make a mistake. Like you comment out that line of code, right? And then you go and add that, git commit, very intentional, smart change. Watch what happens now when I push that up to GitLab. Again, it'll be waiting for the runner to be free, right? Waiting to the runner to be free, still waiting. And then soon it'll be like blue because it's running. Now the runner's actually running it. It'll be blue for a short moment, maybe like 10 seconds. The runner's got to do a little bit of setup, but then it's pretty much just the time it takes to actually run the code. This is it doing some setup, and now it fails. It shows us that something was wrong. It shows us that some tests failed. And now you'll see on the repo, it actually comes up with a cross here. So this is super, super useful because this is run on every commit you push. Therefore, right, you don't have to do much work sometimes. You have this like sanity check. It's a convenience. You don't need it because you can always run those commands locally, but it makes your life easier, which is really good. So we can uncomment that to make it work again. And now let's play around with it a bit more. Let's add another couple of commands just for fun. I'll run echo hello, echo there. Right, so let's add a few, and this is YAML, right? So these are 3 items in a list. So, you know, git status, I'm gonna add them all again. More testing. Again, sorry for cutting some corners there. I'm just trying to respect your time a bit. Okay, so same thing, you'll see it running. But have a look here. Now look at the pipeline. There's still one job. But there are 3 parts of this job now. That's quite interesting. So just because I've got 3 items here, it will run one at a time, right? You'll see it'll run them all. 1, 2, 3, but they're all part of one job. How do I split them up into multiple jobs? Well, what I can do is just give each job a name. So in this one, I call it sanity. I might call it testing. And let's go back to what we had before. But I can actually just copy and paste this block. So this one, I'll call it like, greet. And the command will be echo hello. And then I'll make another one called farewell, which will be like hello, goodbye. Now let's see what we get here. I'm just going to, add commit push. Sorry, it's the wrong page. So we'll come back up to our repo here. Pending. But we got 3 jobs now, right? 3 separate jobs. So these jobs now all run independently, which can be useful. It can be like easy because then you can pass one, pass another, fail another, and so forth. But that's just one way of splitting it up. What we can also do is break that up even further by creating different stages. So you'll see here I've got one stage. I don't love how this file is configured. I think it's a bit hard to read, but the idea is that every single thing you have here is a job, and each job can be grouped into a stage, and you can list stages up here. So for instance, I could have a stage called checks, and I could have a stage called, messages, and my hello and goodbye could be in the messages stage, like that. So now, when I push that change up to GitLab, you'll see its structure is also different. Its structure now has like 2 sections. So still 3 jobs. There's always 3 jobs, but the kind of stages of how you can break it up into different pieces. And I don't know the exact... I think the way it works, I could be wrong. I haven't dealt with this too extensively on GitLab, but you can play around with it in a certain way that like everything in a stage needs to pass, but then you can pause the next stage, and there's a lot you can do, and we do a few things on the back end, like hiding behind the scenes on the course to make it work, right? But that's it running the pipelines. You'll see it eventually succeed that one. The testing one will take a few more seconds, obviously, because it's got to like actually test it. Now it works. Everything's ticked, all good, right? Pretty straightforward. Pretty fun. Yep, we've kind of played around with that near the end. Okay, so an important question. What do you have to do with this? We've done all this stuff today. Now, again, thankfully, today's lecture is so kind of, both this and the last one are very theoretical in the sense that you don't actually have to do anything. We give you these configuration files in the course. Where will we give them to you? Where will we first expect you to start using them? Well, for your labs, it's going to be next week. Typically, we assess things in your labs the week after we have these lectures. For your project, it's iteration 2, which is week 5. So you've actually got week 3 and week 4 without this. So it comes in week 5. For your labs, it comes in week 4. Some groups may want to try and put this in their project for iteration 1. You're welcome to, but what I would probably ask is that when you submit it, you get rid of it. Because it's going to affect how our iteration 2 changes come in. So feel free to play around with it as much as you want. Just whatever you submit, please don't include it. That would be great. So in summary, continuous integration helps us make frequent code changes because we can write tests, write implementation, push to GitLab, add merge requests, right? Make sure we have the green tick and merge it in. It's a convenience. It makes things easier. You can do them faster. It doesn't let you do anything you couldn't already do in reality, manually, but it's a huge convenience, right? Tony says, is it how our labs are marked? We do use GitLab pipelines to mark some labs. Yep, definitely. Valoranova says, do hackers hack our laptop and use it as runners? I don't think that's a motivation to hack your laptop, mostly. William says, if it's a runner, what shoes does it wear? It's a good question. I'm not a shoe person, but I'm sure there's a good answer to that somewhere. Cyril says, could we have a non-strict pipeline which just tests if the code works but still allows the code to be pushed even if it fails? Yes, I mean, to be clear, the code is pushed. Like, pipelines rarely stop anything. Its main use is honestly its main use is it's like a sanity check in case you're forgetting to test your code as you push it. It'll still push it, it just will come up with a cross. But the main one is that, GitLab is set up to typically not allow merge requests to happen into master unless it's got the tick. So if you've written good tests, like if you've written perfect tests and you don't let code merge in terms of the implementation until you know it works, then in theory, this continuous integration stuff, it'll make sure your code is perfect, right? It'll guarantee it to work, so to speak. Very interesting. This is a bit of a visual representation of how this kind of stuff is thought about, which is like, you do some coding, you merge it in, or you go to merge it in. It gets built, it gets tested, you get feedback with the crosses and the ticks, and then you move on. And that's the new master, right? So it's really just about like taking a pause where you used to not pause, doing a few things and giving you some information back. That's really it. The most important thing you need to take away from this lecture is that your master branch should always be green. You shouldn't be merging code if it's not green. In some cases you can, but it will be like a penalty to your group if you merge in code when it's not green. This is something that you should try and implicitly practice in iteration 1, though. Even though we don't have pipelines, and the reason we don't have pipelines in iteration 1 is just to make your life easier. It's just one less thing that we're hammering you with early on. You should still have a habit of never, and I mean this, like never merging any branch into master if npm run test, the Jest tests fail. Ever. You might be thinking, like, oh, well, how do I write tests before implementation then? Like, you might be thinking, oh, this is kind of hard or scary because, what if I go and write like a couple of tests over here for I don't know why they were lines, like 2 tests for implementation that isn't ready yet. It's like, well, don't merge it in yet. Go and write the implementation for those 2 tests. And then take all of that once it's all good and then go and merge all that in, right? Like then go and give it the tick. Because the problem a lot of students make is that they'll go and write these huge bed of tests, right, with like lots and lots of tests. And then they'll be like, oh, it's failing the pipeline because all the tests fail. Of course they fail. There's no implementation for it. And then it's like, oh, crap. To make it work, I have to go and implement everything. So, you go and implement all these like other things, right? And then like by the time you actually go and take all of that and get it to pass, the code's massive. And it's like, nothing's been in master for a week. You've been like camping on the branch and it's just like a nightmare. So your attitude is always to like write as few tests as possible. Write the minimal amount of tests that you need to write the minimal amount of implementation. Then go and take that, put a merge request in, run npm run test yourself. If it passes, merge it in. In this iteration, in your own time you can, but then in next iteration, we'll basically say you can't merge any code in without, going through that process of writing the test, then everything else. And your tutors will check this as well. So even without the pipelines, your tutors will still go through your commit history and make sure you are committing tests before your implementation. So just be wary of that. There's some further reading on continuous integration if you want, but other than that, we're at the end tonight. Do you have any questions before we wrap up? Otherwise, I'd love some feedback, just like always. Give you like 30 seconds to ask anything you want. Balleranova says, is BIOS an interface for charging? I don't know if it's an interface for charging, but I don't know. It's a good question, actually. William says, wait, so we're advised not to write tests for iteration 1. No, that's not what I'm saying. We're saying that, like, you write tests for iteration 1, do all of that, right? But you aren't expected to set up the GitLab continuous integration pipeline because it's not part of iteration 1. We're talking about it now for iteration 2 later on, you know? Jacob says, so we're not supposed to merge just tests into master, right? Correct. If you go and read the spec, it says that, you know, you should like write your test, then write the implementation for it. And then once the tests are passing, you merge that piece of code in. That's the right practice because it's good habits to build, because otherwise all that happens is when you go and put pipelines on things, they just fail, you know, because things aren't working. If you accidentally did that, that's okay. In the past, we've been much more militant with groups in iteration 1, but we've been a bit more relaxed since last term. It's something I'm trying out, and it's just a little more pressure off because. But the point is not to do it because, like, if you make a few mistakes, you're gonna lose a ton of marks. It's more like get into the habit, because next iteration you'll need to make sure it works fine, you know. So please, you know, be conscious of that. Cyril says, what do we do if we merge and the continuous integration fails? Do we revert the merge? Typically, you just make another merge request that fixes it, and you merge that in. That's usually the standard approach. Yeah, so it's less reverting and more just patching it, so to speak. Derpy asks a great question, which is, will there be more on Jest? I feel like I don't know much about how the testing aspect works yet. So there's a lot of Jest in the week 3 labs, and then also in the week 4 labs to an extent. Yeah, like in week 3 and 4. But Jest itself isn't very complicated, and I think that's something to kind of keep in mind, is like a lot of what we ask for you early on, it's really the exact things that we showed you where you just got describe, test, and like most of what you're doing with Jest is not actually like using that much of Jest. I'd say that the best thing you can do with Jest, right? Go to the Jest like getting started page and go, I can't remember where it is. I normally Google it. It was like Jest. Usually I Google Jest expect. Because a lot of things, like a lot of Jest, honestly, is just like, oh, if I jump back to lecture 2.3, a lot of Jest is quite honestly just, do I have some, a lot of Jest is this exact thing, except that you have different setup and you do a different expect. That'll be true for most of the course. Everything else you do, and the complexity of this is typically not to do with Jest. It's typically just to do with, like, you know, what you're actually testing. So it's not really a ton to do with Jest. The only thing, honestly, with Jest that you often need, like, you can just copy and paste this example and modify it in nearly all cases. One of the only things is that when you start doing things like comparing arrays or comparing objects or comparing strings or a few other cases that aren't just like, is this string equal to that string? That's where you need to kind of go and read the Jest expect API, which you can do just by Googling Jest expect. And it shows you a whole bunch of stuff, you know, like, you know, to be or to have returned or to have length is a great way to check what an array length is. To be greater than, so if you want to check if something's greater than something else, you know, there's like a lot here that you can go and look up. But most of the time, all you really need is like to equal and to contain, to match. So, you know, just go and read it. And, you know, I know it's a little bit confronting at times, but again, part of this course is to say, again, when you do 1511, it's like spoon feeding. And when you do a third year course, it's a lot of like, good luck, you're on your own. And we're here dealing with somewhere in the middle a little bit, you know, that's kind of it. So we're kind of like, here's some Jest examples. Let's talk about Jest for half an hour. And, you know, it's a very basic thing, but we're not going to go and step through 30 different things in the API. You can kind of Google that and have a read through yourself and discuss with your team members. You know, that's essentially what we're doing there. So if you are kind of feel like you don't know enough about Jest, what I'd say is that there's a good chance it's not to do with Jest. It's just that writing tests can be hard. You can look at some of the lab solutions as they come out, because remember, we released lab solutions really early. So if you struggle with the week 3 labs, they come out next Monday, like in less than 7 days by a couple hours. And we also have, like, remember, like, don't forget, we released to all of you a repository that you can find called practice activities. And I'm pretty sure, like, most of these practice activities, like if you go to like the week 3 practice activities, there's a few different activities that all have like, okay, that one looked a little bit broken. You know, you can look at stuff like this. You know, there's lots of stuff we've given you, you know? So you can go look at the practice activities. Remember, you can get it just by going to this link. It's not too hard. You can just follow the link. It takes you to the right places. We've set things up quite extensively. So that's it for tonight. Thank you for coming. Leave some feedback. If you have any other questions, please post on the forum. Don't forget, we have a lecture on Wednesday. We will talk about some very interesting stuff on Wednesday. So come along. Remember, again, we've made some changes to the course that mean that lecture content is taught much earlier than you need to worry about it. So what you learn about this week has no bearing on anything you do or submit this week in your own project or lab, right? Everything here has nothing to do with iteration 1 and nothing to do with lab 3. It all starts coming from next week and the week after. Just like this week is where you're going to first start doing testing and NPM, because we talked about it last week. So don't get stressed if you're watching this lecture in week 3 and you're like, oh my God, I'm scared. We have lots of time to figure it all out together. So please have a good night. I'll see you on Wednesday at 6, hopefully, if you're there. And yeah, keep at it. Keep up the good work. The next couple of weeks are where people start to fall off the wagon. So keep your focus and you should be good. Cool. Thank you, everyone. Have a great evening.